All right, this is model problem 1 for designing a study, our first part of our flip lesson. So an AP statistics exam, and this was on the AP statistics exam in 2011, it was question 3. An apartment building has 9 floors and each floor has 4 apartments. The building owner wants to install new carpet in 8 apartments to see how well it wears before she decides whether to replace carpet in the entire building. The figure below shows the floors and the apartments in them. Only the 9 apartments indicated with an asterisk have children in the apartment, and then it's important to note that they have that for you right there. Okay. For convenience, the apartment building owner wants to use cluster sampling method in which the floors are clusters. Okay, so you want to be careful here and make sure that you're following what they say and actually do the clusters the way they tell you to select 8 apartments. Describe the process for randomly selecting 8 different apartments using this method. All right, so the first thing we're going to want to do was with the floors, we want, they're already numbered, so we don't have to number them, but we do want to list out in our instructions that the floors are numbered. So the floors are numbered 1 through 9. So that's the first thing. You want to number whatever you're working on. Then we are going to use a random number generator to select 2 floors because that would give us 8 apartments. And those apartments would get new carpet. So okay. So once we've numbered the floors and we've selected our 8 apartments that are gonna get new carpet, we want to measure the wear and tear on the carpet. And that's going to be like the last part is measuring our response variable. Okay, so that is how you would work that question. So let's take a look at part B. Part B says an alternative sampling method would be to select a stratified random sample of 8 apartments, where the strata are apartments with children and apartments with no children. A stratified random sample of size 8 might include 2 randomly selected apartments with children and 6 randomly selected apartments with no children. In the context of the situation, give one statistical advantage of selecting such a stratified sample as opposed to a cluster of 8 apartments using the floors as clusters. Now, here it's important to note that they are not asking you to re-engineer like the process for how you would get these apartments. They're only asking you why it might be a good idea to do this. So you want to think about the kind of things that kids versus no kids would have, the impact that would have on an apartment, right? Kids are traditionally more hard on things like carpet and flooring. So children may wear and tear carpet more or differently so a stratified, sorry y'all. pen got away from me there. This stratified sample guarantees sorry, y'all. So it guarantees apartments with children and no children are in the sample. Which gives you the ability to be able to compare children versus not children. So in the context of this situation, give one statistical advantage of selecting such a stratified sample as opposed to a cluster sample. So the problem with the cluster sample here, if we look back at it, if you'll notice, there are 1, 2, 3 floors without any children. So you could potentially run a sample here where you don't get any kids and you don't get to see whether or not there are kids, like if kids have more wear and tear on the carpet, which could impact your ability to like draw conclusions. So here, the cluster sampling method could choose two floors without children. Right? And that's it. That's all that you need to have to get full points on this problem. Now on model problem 2, this was from the statistics exam in 2008. A local school board plans to conduct a study, a survey of parents' opinions about year-round schooling in elementary schools. The school board obtains a list of families in the district with at least one children in elementary school and sends a survey to a random sample of 500 families. The survey question is provided below. A proposal has been submitted that would require students in elementary schools to attend school on a year-round basis. Do you support this proposal? And then you had to answer yes or no. So the school board received responses from 98 families, with 76 of the responses indicating support for year-round schools. Based on this outcome, the local school board concludes that most families with at least one child in elementary school would prefer year-round schooling. Right? So here what we would do if we were going to run some sort of test is we would find a p-hat and then use that p-hat to run a 1 proportion z-test. That's, however, not what they're asking us to do. They want us to like weigh in on whether this is a good design study. So what is a possible consequence of non-response bias for interpreting the results of the survey? So one of the biggest issues that I see is that they sent surveys to a random sample of 500 and not even a fifth of those responded. Okay, so they conclude, the problem with this is they could conclude to start year-round school when really the majority does not agree. The problem with that is you'd probably have some really angry parents. All right, so that's one of the downfalls of the non-response bias. So someone on the school board advised the local school board to make an additional random sample of 500 families to use the combined results to make their decision. Would this be a suitable solution? So no, you can't just send out another survey and then combine your results. That doesn't deal with the original bias, right? So no, combining results does not eliminate the non-response bias. From the original sample. Okay. So since we've decided that that's not a good idea, we want to suggest a different follow-up step from the one suggested in Part B that the local school board could take. The best possible thing is you already ran a random sample of 500 families, so you need to follow up. Ooh, sorry, y'all. Up with the 402 families in the original sample that did not respond. Okay, and then that's it. You're good to go. So that concludes the model problems for the first section of our AP review. I look forward to making another video for you later in the week.